Alright, so I got a piecewise function here with 3 values. Now you'll notice something here when you guys are graphing it. You'll notice that on the restricted domain, everyone say restricted domain.
Restricted domain.
On this part they call it restricting the domain. Restrict domain. They're telling us where the piece starts and where it ends. Okay? So I notice a 2 here, and I'm going to put my 2 here. Now this is not an asymptote. Okay, this is not an asymptote. It just kind of tells us where things start and end. And you'll also notice something at -1. And you'll also notice something at -2. Okay, so I'm just putting there as a visual, so when I graph it, then I need to do something there. Erase it, open or close. Alright? So the first thing I see is f of x equals 1. Yesterday we learned that if you write f of x equals 1, an easier way of saying f of x is y equals 1. You can make a table of values, and basically you're graphing a constant here. So all of your y values are 1, and you're just making up your x values. And you go ahead and graph that. Pencil so I can erase. Alright, so I got -1, 1, 0, 1, 1. Everyone say a constant?
Constant.
They call this a constant. It's just a number there. Now it tells me something at 2. I want numbers that are bigger than 2. So class here, open or close circle?
Close.
It's a closed circle because it has an equal sign. So this one in pink. Class, where are numbers bigger than or equal to 2? To the right. Numbers that are bigger, 3, 4, 5, 10, 1,000, right? Raise your hand if you got that one so far. Let's go ahead and erase the rest. So that's the first part. Okay, second part, it says f of x equals x. Okay, now if you're stuck on that, I just want you to think about, well, what do you know about linear equations? You can put that in slope-intercept form, right? Y equals mx plus b. So for you, you might have to add a 0 here for your y-intercept, and you might need to write a 1 over 1 for your slope. So I'm going to start at 0, and I'm going to go rise of 1, run of 1. Up 1, right 1. Up 1, right 1. Now you can also do the same as true, -1 over -1, right? Down 1, left 1. Down 1, left 1. Go ahead and graph it. Some of you guys are starting to predict where you actually need to draw this line. Thinking ahead. It says I need numbers only between -1 and 2. At -1, is this open or closed? That's going to be a closed. Let's do some blue. So at -1, I have a closed. And how about at 2? At 2, any numbers that are less than, so that'll just be here. So it's basically between numbers -1 and 2. Keyword and, right? Now my open and closed circle is a little bit too big. It's fine. It's just to show you that at +2, something's happening there, right? Okay, they're actually not touching there. They're discontinuous there. And let's do the last one. This one says -x. So you can do -1 over 1 as your slope, and you're still starting at the origin. So start at the origin. Rise of -1, so down 1, right 1. Down 1, right 1. You can also do the reverse, right? You can do 1 over -1. So that would be up 1, left 1. up 1, left 1. Here is my linear function. Let's do this in orange. Open or close, class? Open where? Open at -2. Here's x at -2, so open. Class, I need numbers that are less than, so go to the left, to the left. Question?
Isn't it -x minus 3?
Did I copy down the wrong problem? Oh, yes I did. Did I?
X minus 3, yeah.
It's -3?
Yeah.
Oh,
X minus 3.
This all over again. Thank you, Greta. -3. And now I'm going to do the same thing. Down 1, right 1. Down 1, right 1. Rise of 1, left 1. Rise of 1, left 1. Let's do this in a darker color so you see that. Green. So now my graph looks like this. And I need numbers that are less than 2. So here, open circle. So ignore the orange. Numbers that are less than are go where? Less than?
Left.
Left. Okay, so you shouldn't have this one. Here are some troubleshooting things. Okay, remember you have a negative slope, so going from left to right it is negative. The green. Okay, blue it's positive, so from left to right it's positive, and anytime you have a horizontal line is a constant. These are not touching, so the graph is what? Discontinuous what? You have a jump here, right? Jump, and you also have a removable. Question?